All right, hey everyone, welcome to this lesson, lesson 3 of equilibrium on the Chatelier's principle. And we're going to be looking at example 1, which is studying the equilibrium system between hydrogen gas reacting with iodine gas, producing hydrogen iodide. Now, the double arrows symbolize that this reaction can go forwards, where these are the reactants and they produce hydrogen iodide, or the reverse reaction could happen where hydrogen iodide reacts to produce hydrogen and iodide. And the double arrows just symbolize that this reaction is occurring in both directions. Okay. What we're going to be looking at in this example and in the other examples today is what happens when this system is disturbed. Okay. And this is called Le Chatelier's principle. It's explaining how the system responds. Okay. Another way of thinking about this is you get punched in the face. All right. There are several ways that you can respond to that. Number one, accept the punch. Okay. But chances are, if you get punched in the face, you are going to want to oppose that change by punching the other person in the face. I mean, I'm just saying. So we're looking to do that in the same way, but applying it to chemistry problems. So in this example, example 1, we are adding hydrogen gas to the system. So we are increasing the amount of hydrogen iodine the amount of hydrogen gas that is in that system. So if we are increasing the amount of hydrogen, okay, if we are adding a bunch of hydrogen to this system, are we going to want to get even more hydrogen, or are we going to want to use up the hydrogen that we're adding? So if we add hydrogen, we want to oppose that. So rather than creating more hydrogen, the equilibrium will shift to the right to use up that extra hydrogen that we added. So we added hydrogen. Rather than making more, we want to use it up. So it's going to shift to the right. So the forwards reaction is favored. Well, so we rationalize that. Okay, we used our brains. We figured out what happens. But now what we have to do is visually draw what happens. So initially, we have hydrogen gas at this concentration. Again, these are just random numbers that I've chosen, but in a real example, you might get some numbers, okay? So in this example, we have hydrogen gas. When we add hydrogen, if I take a bunch of hydrogen and just pour it into the container, the concentration immediately goes up. Okay, so I draw a line right here. My hydrogen immediately goes up, it spikes, okay? But once it spikes, the system says, oh, I don't want any more hydrogen. I want to use it up. So its concentration is going to go down. Okay, it's going to decrease. So although it spiked initially because we added it, system's like, nah, I don't want any more. It's going to go down, and then it's going to stabilize at equilibrium. Okay. Now, what you notice about the initial equilibrium, it's a straight line. The response is not straight because it's adjusting, but the resulting equilibrium is again a straight line. Well, what's going to happen to iodine? Is iodine going to spike up or down? No, we didn't add or we didn't take away any iodine, so there's no spike. However, if the reaction is shifting this way, the forwards reaction, and we're going to be using up hydrogen, that also means we're going to be using up iodine. So iodine's concentration is going to be used up. It's going to go down, and then it's going to stabilize. Okay, well, if the concentration of hydrogen is going down and the concentration of iodine is going down, what's happening to the concentration of hydrogen iodine? Well, the reaction is shifting to the right, so in theory, we should be getting more hydrogen iodine, so its concentration is going to go up. Okay. Again, it could go up all the way here. It could go up just below. I'm just putting it in the middle so you guys can see kind of what's happening. But again, this is just an approximation of what's going to happen. But if we take a look at this, what we've noticed, okay, is that, make that a little nicer, okay? So hydrogen initially went up because we added it and then restabilized by decreasing. Iodine restabilized by decreasing. Hydrogen restabilized by increasing, and these are now our new equilibrium positions. All right, and equilibrium has been reestablished.